Question 8. Consider the two complex numbers z and w, where k is positive integer. Find the modulus of them. Find argument of them in terms of k. Suppose that they belong to integer numbers. The w belong to integer numbers. Find the minimum value of k. For the value of k found in find a lot of tasks. First, let us find the modulus. Modulus, so we have real part and imaginary part. Not real part and can I say it? Module and argument, not the real part. This is module and argument. Module and argument. So when we multiply numbers, modulus multiply, so we get 16. When we multiply numbers, argument add. So we get something like this. And it should be multiple of 5. One minus 2k should be multiple of 5 because we need real integer numbers. C. Find the common value of k, a minimum value of k. So because argument belongs to integer numbers, 1 minus 2k is multiple of 5. K belongs to positive 0, by guess minimum of k is 3. So for 3 we are getting minus p. Finally, this is the result. When you multiply z by w, you are getting modulus 16 cosine minus p plus sine minus p. Section B. Consider function. Find the x-coordinate of p. So we have some function. Y equals x intersected. We should find point P. Also, there is line that has this -1 gradient and at point Q. Right, so I should split screen. Otherwise, it will be not possible to explain. Right. Okay. So we are finding point P. Again, we use calculator. One function is, so let me do it once at least. So we press y equals, here we clear, right. So one function is y equals x, and another function is, I don't know what, which, 90 exponent minus 0.5. Just a moment. Another is 90 exponent minus 0.2x, I guess. 0.2x. This is how it, okay. Let us use zoom. Okay, let us use zoom standard. Zoom standard is okay, but something is wrong with my function. Just a moment. My function 0.2x. Probably I didn't put proper minus here. It should be special minus, this minus below in the brackets. Still didn't work. Lesson 9. Two boats A and B travel due north. Initially, boat B is positioned 50 meters due east of boat A. The distance traveled by boat A and boat B after t seconds are x meters and y meters respectively. The angle of theta is the radian measure of the bearing boat B from boat A. This information is shown. Show that y equals x plus 50 cotangent theta. Find this at time t, the following conditions are true. Boat B travels 10 meters further than boat A. Boat B is traveling at double speed of boat A. The rate of change of angle theta is minus 0.1 radian per second. Find the speed of boat A at time t. So first, using geometry, we are writing this relations. Then we differentiate it, and we take into account that the theta by the t differential by time is minus 0.1. Then we recall that velocity of boat B is 2 times more, so we put here 2 dx by dt, and after substituting all known values, we find that velocity at the beginning at time t of x of boat A is 52 meters per second. Section B. Section B considers a function defined as 90 exponent minus 0.5x. The graph f and y intersect at point P. Find the coordinate of point P. Line L has gradient minus 1 and is tangent to f at point Q. Find the exact coordinates. Q shows that the equation L is y so much. The shaded region A is enclosed between the function f and the line y equals x. So I need to go to my solutions. So view, split, solutions. First of all, we find intersection of function y equals x and our function. And we keep three significant figures. Coordinates, don't forget to put also y coordinate. About point Q. Q has gradient -1 on the function. It means that derivative of the function is -1. This happens, if you follow this logic, this happens when x equals 2 logarithm 45. And the value of y will be 2. So we know the position of point Q. Line L is tangent to f of -1. Shows that L equals so much. Use point Q and gradient -1 and use formula y minus y1 equals gradient x minus x1. You get this function for this line. Find the coordinates of point where L intersects y equals x. Hence find the area. Line So we have the same symmetry of lines, and we see that point A is y equals x, but has gradient -1. So right here is the solution. Point A, line Q intersect okay, so we x or y doesn't matter. Total area consists of two parts. One part is from A to P, another part is from P to Q. So you know that to find area you should integrate, and if you have several lines, you integrate, find a total area and subtract lower area, and you will get the result. So here I found two sections, and I didn't calculate it, just here how they look in my presentation, and here how they look in mark scheme. Line L is tangent to the graph of both f and inverse f minus 1. Find the shaded area enclosed by the graphs of f and inverse f. By symmetry, areas should be doubled. Line L is perpendicular to line X, so gradient 1. One point we know, Q. We put this Q and we find the formula for line L. Question 11. The denominator should be not 0, X not equal. So we have two values, P not equal to -1/2 and Q equals 1, 2. Find expression for f prime, just differentiation of ratio rule. Find x coordinates of point of reflection. Method 1, I'll use method 1. I write the function, then I write it as a differential, and I found the point where this happens. So point is 1.6, y equals 0. Sketch the graph of fx showing all details. Okay, let's take off anything extra. So here my work. So we know that asymptotes, vertical asymptotes, happen at x equals -0.5 and also at 0.5. That there is vertical asymptote y equals 0. Maximum we can find, y-intercept we can find. Point of inflection. Okay. Is second derivative is 0. Next question. The function g is defined by g dt. Find the equation of all asymptotes of graph g by considering g minus f, otherwise find. Okay. So x equals horizontal asymptote. Is it right? X equals -2/3. Oblique asymptote we can find because we divide polynomial with degree by 1 more. So here x squared. So we divide, and quotient give us this oblique asymptote. So here we have graph, vertical asymptote, for some reason I forgot to put for 3, when we divide, let us see, when we divide, we should get positive asymptote. Strange. And here I don't see vertical asymptote. Probably this is another function. This is a function f minus g. To know that in which areas g is greater than f, we just draw graph g minus f, and when it is positive, g is greater. When it is negative, g is lower. Next, question 12. Function f has derivative like this, where k positive constant. The expression for this, right? So they give us example how to transform such form into such form, and even how for such form it is easy to find logarithm. How we are going to use it? So we have some margins. I'll change margins. Arrow. Okay, right. So they give us example how sum can be turned into ratio and how easily it can be integrated, and we use this for population of ants. So they give us formula. We can transform this formula into the formula that we had before. We can take logarithm. We can rewrite, and finally we get this value. Then they say at time t 10, population is doubled from its size. So please find value of k with 4 significant figures. Value of time when rate of change is maximum. So doubled means 2400. So blue graph is graph of population, and we find so from this information we found that our parameter k is 2845. Then nicely we take our function differentiate it. Red is differentiation, and we see that the maximum rate is at time 1.51 day. So here I use some trick. Let me show this trick. For example, you have some function and it is very complicated. But you're not interested in the function itself, but you're interested in the derivative. Okay. Derivative is 6. Oops. Derivative. We need n derivative. 3. Not here. Here. We need derivative. Here. So screens are different. In different screen you can work differently. Okay, so our variable is x. And I want to see derivative of y1. So I put here alpha f4. Here you are. You have function. So we will have function and its derivative. And this is derivative. A bit different here. Yeah. So I think this is the last question. To tell the truth, this paper is so confusing, so confusing. I have no words to say. Please, if you have questions, something I didn't explain well, because I'm a bit sick, in the comments you can ask any question about any point of this paper. Thank you very much for your attention.